So what are we going to talk about? Well, this thing called real-time analytics. What is that? I'm the only guy at Microsoft, I believe, that hates the word BI. I can't stand the word BI. Because we displayed it as a bunch of these cool tools, and we show you all kinds of cool stuff, but the customer problem is simple. They want answers to questions. To me, that's analytics. The other stuff doesn't matter. What you use really doesn't matter. It's basically, as fast as you can, answering questions for customers. So my role at Microsoft is I manage the customer-facing team for the data platform group and for the Windows Azure group. And you've probably heard of the CAT team. Maybe you might have heard of the CAT team, the SQL CAT team. Now we call it the Azure CAT team, which is just what I call a superset. SQL CAT is still in there. We haven't gone away, same folks. And our job is threefold. One is we own the advisor groups that provide input into our planning. So this is obviously the MVPs, all the people that participate in all our programs. We own the advisor group. We run the early adopter programs. We call it TAP. And then I have the traditional CAT team where I kick them out of Redmond, Washington, at least 50% of the time to work directly hands-on with customers. And typically taking on, that's what I call the tip of the iceberg, the largest, most mission-critical systems, things that no one else has done before. And the goal is basically to learn from it. And they learn from it, and they come back to Redmond, they sit down with Jim and his engineers and Jim's peers, and they explain to them how the product's really being used by our customers, where are the white spaces, where are the gaps. And either we have the engineering fill them, or we'll fill them ourselves through producing blogs and papers and sample code, et cetera. So that's what my team does. I myself, I go talk to a lot of customers, and many of them are CIOs, and it starts with this thing called analytics. It's like every customer wants to talk about it, and every customer wants these questions answered quickly. And that's the problem I'm trying to solve. So I call it real-time analytics because I truly believe you can make decisions right away. Anybody driving in a car and see the check engine light come on? Everybody, right? We all had that happen. All that is the car is dumping alerts into the computer in the car. Somebody's, the computer's sitting there watching the alerts. It sees something. It says, I have a problem. And boom, the check engine light comes on. That's the analytics. That's real-time analytics. Matter of fact, it just happened to me. I was taking my daughter to the university, and I'm driving to Boston, Massachusetts, and going 80 miles an hour on a 4-lane highway. And my car thought it would do me a favor because it recognized through alerts that my transmission was having problems, so it shut down my transmission for me in the middle of going 80 miles an hour. Just so happens that it was wrong. My transmission was fine, and the computer was wrong. But anyway, so real-time analytics are good, and real-time analytics are bad if quality data is bad. So what am I going to do now for the next 50 minutes to an hour? I'm going to take this space of answering questions. All right, what do you want to call it? Analytics? That's what I call the whole big space. What do you want to call it? Data warehouse? What do you want to call it? Real time? And I'm going to try to get you to think you can do it faster than you do today. That's it. You can do it faster. Any component of it can be done faster than today. I promise you, if you do it faster than you do it today, no one will complain. All right? That's the culture that I'm going to try to take you through, whether it's from the traditional data warehouse at one spectrum, or whether it's just real time at the other spectrum. Every component can be done quicker, and the technology's there, and you need to think that way. And I'll show you a few ideas of how you can do that. All right, so we'll get started. I'll jump into maybe a traditional, and I'll walk you through it. Interactive is good. There may be even incentive, hint, hint, to be interactive during this session, okay? I won't tell you what that is, but we'll just get started and see if I can get you to be interactive. So let's start with the IT professional, and this could be anybody. This could be the database administrator. This could be the guy who purchases hardware, person who does system administration, configuration, but let's take an IT professional, in this case, data professional. And let's look at a traditional data warehouse. You know, the one that starts with line of business apps. All right, data exists, I gotta find the sources of the data, and then I gotta turn around and somehow put it in some type of curated format so it could be consumed by the person who wants to answer questions. All right, so this is traditional. And what happens here? Well, first of all, we have to find the sources. So we have to go, obviously, march over to the person in the end user area, my analytical person, my business user, and say, what do you need? Do they know what they need all the time? Not really. So we're going to go find them some sources of data, okay? And then, you know, we decide how we want to present it to them. Maybe we store it all into a data warehouse, and maybe what we do is we take that data and we build the perfect data model. All right, this is kind of this religious argument because some people believe in the perfect data model. Amen. Some people believe in, you know, the data has to be so perfectly curated. So I write ETL jobs for 9 months. All right, hallelujah to those who believe that. And some people just want answers. So whether what you believe, part of this presentation will be applicable to you. All right. And I think give some examples. So we have the perfect data model. We might decide that it's a cube or it's a data warehouse. Doesn't really matter. All right, so we're going to build that. All right, and then what do? We might turn around and, you know, after we do the staging of ETL, we might turn around and create reports. We might give them to the end user ourselves as data professionals, or we might even today allow the end user to write their own reports. Maybe it's Excel. And what does that user do in Excel? Well, they turn around and they send it to their friends. And all of a sudden, now it's out of your control. Their friends have it. They might massage it and change it. Does it ever get back to that perfect model you had before? No, it's probably copied someplace. It's probably making decisions off old data. And how long does this take? I don't know, 18 months, 9 months, 3 months, weeks. Depending who you are, and everybody could give you different experiences how long this takes. Again, I am just going to introduce you to different means of possibly making this experience faster. All right? So, what is our goal? Our goal is to make it faster. Do you believe in real-time analytics? The actual example I gave you about the check engine light, you know it's happening. All right, but there's a lot of places it's happening. We work with Lotus F1, pretty cool customer, have some fun. And what we do with them is we actually take data off the car that's racing, and we turn around and put it on monitors so people can watch it live, the support crew, so they can make decisions on how the car is performing. Do I need a pit stop, et cetera, et cetera. Well, that's all happening in how fast? Microseconds, milliseconds at worst. And that's basically analytics for them. And to do that, you can't do the traditional data warehouse that I showed you the slide before. You almost have to flip it. You actually analyze data before it ever gets persisted. The data warehouse actually gets created, all right, after you actually look at the data. That's kind of a flip thinking on data warehouse. So in this case, the data comes in right off the car. Data doesn't get persisted. It just sits right in memory, and it's processed. Here it comes. I'm looking at it. And by the way, of all these data warehouses, how much of that data never gets looked at? Sometimes 80%, 90%. One of the best tuning things you can do for data warehouse is throw your data away. Do we do that? Of course we don't do that. We just put it all there because you never know. I'll probably need it someday, right? Yeah. I won't pick on my wife, but she does keep a lot of shoes around for many, 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 many years. But anyway, so data comes in off these cars, and we throw data away that we don't need. We're going to turn around, then we turn around and data that we need to act on, we see something, we write in memory, we provide query processing against this using the Stream Insight product from Microsoft, and we look at it, we say, oh, this is important. Send it to the monitor, or send it as a red warning flag, or execute this job. Well, then after that, we might turn around and put it into a data warehouse. All right, so this is real. This is real time exists. So assuming this is real, and that's nirvana, that I can make decisions off data as data is born, that will be kind of the goal. And to do that, you have to use things like stream insight. You have to persist data after you look at data, things like that. Assuming that's nirvana, but that's not reality. Some applications are alert and event driven, but many of them are, I have to look at data over the last 7 years. If you look at data, looking at data over the last 7 years, you're probably not all events and alerts. You're probably storing it and analyzing it over time and doing graphs and things like that. So there is a combination of not everything can be real. All right, but even if you're going to build some type of range between a 7-year data warehouse and real time, again, there's different things you can do fast. And some things I'll introduce you to is, again, the flipped idea of maybe I build a data warehouse by looking and analyzing the data first, then creating the data warehouse. There's a concept at Microsoft we call leave data where data is born. If you want to process data quickly and the data is unstructured, why are you spending who knows how much development time trying to make unstructured data structured? That's kind of what's provoking this big data thing. All right? People realize that, hey, the fastest thing I can do is to leave unstructured data unstructured, move structured data, keep structured data structured, and then give everybody the ability to access that, process it quickly, and give them the right tools to do that. All right? So that's what I'll be showing you. To leave data where data is born. There's a lot of little things that you can do too, because remember that traditional data warehouse, any one of the pieces can be done faster. How long does it take to purchase hardware? Does everybody have that hardware group? It's probably people in the audience now. Your job is to analyze and purchase hardware, and you analyze this vendor versus this vendor versus this vendor. Well, then you order it, comes into the docks, and then somebody takes it off the docks, and somebody puts it into the data center, and then somebody loads software, and then somebody configures it. How long does all that take? All right? What if there's other options to that? So again, we'll get you to think of, no matter what section you are, no matter what job you have, hopefully you think we can do it a little quicker. This is the real app. It's not in production yet, but the CAT team was working on building this and designing this. And it shows a little bit of everything. So I'm going to kind of take you through this. On the left-hand side is devices, phones. I know I made them all Windows, but I realized that everybody has a Windows phone. All right, but there are devices. Everybody does have a phone. Some of them, you have 2 or 3 phones. So there's a lot of these things called devices or phones. And this application thought, I mean, how many apps do you have that uses the GPS locator? Almost all of them now, right? I mean, it's just there. All my apps use it because it provides me a better service if you know where I am. Well, this app, these guys came up with an idea. What if I can, based off who you are, what's your profile about you, and where you are, and where you're going, what if I could proactively give you coupons? So consider this. I'm walking down the street in Seattle. All right? It happens to be First Avenue. And somebody's tracking me, because I allow them to. There's rumors that people in the USA track people, but we won't go there. All right? And I'm walking down the street, and all of a sudden, every few seconds, somebody knows my location, knows who I am, because I volunteered I like coffee. All right? I had a couple of doubles this morning, and I have another cup here, and I'll probably have another one later. All right, I like my coffee. They know that. I'm walking down the street and they notice that I'm going north. And all of a sudden on my phone pops up 50% off Starbucks coffee. And son of a gun, right in front of me is a Starbucks.
Of course, in Seattle.
Oh, that's true too. In Seattle. Bad example. Bad example. All right, Seattle's best coffee. Let's go with something else. You're right, it's a bad example. I'm in Seattle. But anyway, and notice that. That sounds pretty cool. Boom, I'm inside Starbucks or Seattle's best and having coffee. So that's the idea of this app. To accomplish that, it's more complicated than you think. You're going to have to constantly grab data, event data or alert data coming off this phone. Location, directional, the profile data, who you are. Keep grabbing that data. And you have to process it right away. So this big box up top is in memory. Ignore the name, it's a code name, but it's in memory processing. So this is the flipped data warehouse. I process it first, never is persisted. I immediately process that data and it says, hey, I got that data, and maybe the unstructured data part of that I'm collecting, I throw into an unstructured source down here. Consider this being Hadoop. All right, maybe I look at data and says, well, it's not useful. All right, I grabbed who it is, it's Mark. Well, a second later I grab it, it's still Mark. Well, I know it's Mark, I can throw that data away. All right, I don't have to store 2 Marks. All right, so I throw some data away. I just move unstructured data into structure. I might turn around in this engine and query Mark, now I know it's Mark, to say, oh, what's Mark's personal preferences? All right, so now I got Mark's personal preferences. I know where Mark is. I can turn around at the same time, make that structured, load it into the structured data warehouse, always do reporting on it, and boom, proactively send back to my device a coupon. A little bit of everything here. The data warehouse is actually created post-processing of the data. Now, let's be clear. I'm not telling you this is how you should build your data warehouse. I'm just introducing you to thoughts that you can think differently, and you should always ask yourself, can it be done quicker? And this is just a good example of that. All right, combination of unstructured and structured, where I can query both today. This is all existing technology, all shipping today. All right, just an idea, just an example. Hopefully you see that. All right, now let's go through some more examples. Let's say it's more of a traditional one. It's not an event alert type analytical situation. It's more of I want to go after some line of business data. Maybe I want to go after some external data as well. And I want to build a data warehouse for my end user. Well, to do it right, a lot of times we do a proof of concept, right? So if I'm going to do a proof of concept, and a typical proof of concept takes 3 months, I'm going to now show you some samples how we can do it. Who knows? Maybe an hour or 2 hours, or even if it's days or weeks, it's a lot better than months. The other thing you have to think about is, if I wanted to, if the end user, if this data warehouse already existed, and the end user wants connectivity to a data, what do? Somebody has to provide that connectivity. Somebody has to give them the data string. So they call IT up, and I'm an IT professional, so I turn around and give them data connectivity. Here's your data string. What if they could do that themselves? What if we provided that capability? So those are the types of things we're going to think about. But let's start with, I want to build a proof of concept. What do I want to do? Let's go through and do a quick demo. All right, let's jump over. My screen is being extended, and so if you give me a second to, actually I think, sorry about that. I don't want to extend my day, I want to duplicate my screen. There we go. That way you can see what I see. All right, now I want to, okay, there we go. All right, you want to do a proof of concept. And again, there might be some unstructured data, there's some structured data, all right? And instead of going through the process of calling up my hardware guys or getting something provisioned, maybe you do something like this. And again, it's a proof of concept, so let's assume we're throwing it away. So I want to create, this is, by the way, you're looking at the Azure portal at Microsoft. All right, and inside of my Azure portal, you can see I have some storage devices, and some in US at different locations. I got one in Northern Europe. I got a database here. I got Northern Europe storage. I got some services, and I got some data warehouses already built. I have a website built. All right, so I have a pretty active portal. I'm going to go down here, and I'm going to actually scroll down, and I'm going to, HD Insight is right here. Now, how many people have done this? All right, about a third. So for the sake of the other 2/3, bear with me on this, all right? So what I'm going to do now is I want to build, this is a Hadoop cluster. All right, and if you ever not set up a Hadoop cluster, it's not easy. You've got to get a bunch of machines. You've got to install all the operating systems. Then you can install HDFS, the Hadoop file system. Then you install MapReduce. Then you've got to configure the machines so all one cluster. Or if you can come in here and say, I want a new Hadoop cluster, all right, and I'm just going to do a quick create, and I'm going to call it SQL Rally Nordic. And how many nodes do I want? I want 4, 8, 32. All right, I need, my user ID is admin over here. All right, so my username is admin. I need a secure password. So give me a second to type in a secure password that's going to pass. All right, and then where do you want to put it? Well, I want to put it in my Europe storage, so Markham storage, and I'm going to create it. That's it. That's it. It's now actually going to spend the next 10 to 15 minutes. It's going to, because these are all provisioned in VMs sitting out in the cloud already, I'm going to now go out and set up that provision cluster. A little faster than going through the process of, ordering, configuring, installing. You're going from weeks to basically somewhere between 10 and 15 minutes. And it'll sit there and it'll actually walk through every step. So that's going to take a little while. Now, by the way, you can also do this with PowerShell. And matter of fact, if you're doing a proof of concept, use the GUI. But if you're going to build one for real, you'll probably use PowerShell. All right, and the reason you use PowerShell, why? Because PowerShell gives me more capabilities. For example, if I'm going to build a 10 terabyte or 20 terabyte cluster, I don't want one storage. I might want multiple storage to spread my data out. We're data people, we understand this. Well, you can't do that in the GUI. It's all single storage. So if you want multiple storage, as an example, you need to use PowerShell. And this is the same PowerShell script that I basically did with the 4-step process over there before. All this exists today. All right, and all you got to do is exploit that today. So I can use PowerShell to do that. So my cluster started, and it has accepted me and who I am, and it's going to turn around and start building that. While it builds that, all right, you can see the Windows. Well, maybe you can't see. Windows Azure VM configuration. It'll stay there for a good 5 minutes or so. All right, now, while that's being created, let's go take a look at my current HD Insight, one that I already have built. And there's a bunch of monitoring dashboard information. I can manage my cluster. It's not quite integrated yet. It's a separate experience, a separate window. But we'll have it all integrated in the near future. But I'll log on here. And when I log in here, I just want to show you the whole process. I create my configuration, which is happening now. I load my ODBC drivers, which, by the way, come with it for free. And here's the site, so I can go right to my downloads and load my ODBC drivers. Mine's already loaded. And now, boom, I have access to the site. I can turn around and grab one of those BI tools and access it, or I can load data into it, or I can do anything I want with it. But that's as much as it takes to get started. That type of thinking, it will actually speed up the process of data warehouse. What's nice about the cloud is after you get used to it, because let's say you don't use Hadoop today, and you don't know if you want to use it or not, but it's trendy, everybody's talking about it, throw it up, develop against it, learn the experience, delete it, it's gone. All right, much better thinking, creative thinking, faster than I do today. So here's a data warehouse example. Also, if you're getting started, we do have a bunch of samples out here as well, all right, with sample code, all right, that you can actually get started with as well. So we're pretty good, including like sample PowerShell if you look out on MSDN, et cetera, et cetera. So this is all out here now that you could use. And you even have a remote desktop where I can get into the site directly. There's a monitoring capability to watch your job history. I can submit job history. There's an interactive console here as well where I can, Hive is the kind of the layer on top that makes it look like a data warehouse. And I can do, show my tables, And this, by the way, will fail. because I did the command wrong on purpose, because I wanted to show you that I can actually track the history of this. All right, so that did fail. Oh no, it actually came back right. I meant to fail it. But anyway, so I actually went out and found a table I can select from it, and only doing a couple of things. So I can go show you that we're tracking all this as well. And what this job does automatically is, now this is going against the existing cluster, not the one I'm creating. I'm still creating the other one. And from Hive, you submit a job, it'll automatically, if you have a 4-node cluster, break it up into 4 jobs and send out a batch out to those 4 jobs automatically. So this is, again, just making it a little bit easier than you have today. All right, so simple, step by step. Obviously, if you want to do more sophisticated stuff, it takes longer. But again, I'm just introducing to you the thought process. I can do it quicker than I do today. I have a job history, and you can see I was going to do some jobs that failed, but I have some jobs that failed out there. You can monitor your job history as well. Okay, so that's an example of creating a Hadoop cluster. So let's go back here, and my cluster is still going. All right, let's do. Maybe you don't want to do it. Maybe you want to do SQL Server. Maybe you want to do a data warehouse in SQL Server. Anybody know what fast track is? Right? We all know what fast track is. It's reference architecture. Microsoft set it up. We actually did all the testing. And if you set your hardware configuration exactly like the reference architecture tells you, we'll guarantee you so many IOPS. All right? You can set that all up yourself, or something that Alexei will show you later in a session tomorrow in much greater detail. You can just go create a VM. All right, and if you've never created a VM inside the cloud, we actually have something called a gallery. All these images are provisioned already for you. There's Windows images. Let's see if I can zoom that in for you. There's Windows images. All right, that ain't working very well. Let me get back out of there. There's SQL Server images, including SQL Server 2014. I'll come back to this data warehouse one in a second. All right, and if you haven't seen this before, oh, look at that. There's Oracle images out there. You can, Java, Linux. All right, maybe there's even Oracle on Linux out there all ready to go. There's even a Azure Data Analytical thing, which has nothing to do with Microsoft. It has R and Python already built out there. So this is just not Microsoft here. You just answer an analytical question. It's faster than you do today. But since I'm a little biased, I do have a data warehouse already pre-configured out there, SQL Server 2014, with a fast track configuration. What do I got to do to get that? Well, I don't know. I got to answer a couple questions. I'm going to call it a name. All right, I'm going to give it a size, and I'll zoom in a second. I want to give it a user and password. The longest time is coming up with a password that they accept. All right, and I typed it in wrong. Okay, and I'll zoom that in a second. That's all I did. No big deal. And then next step is, do I want a new cloud service, or do I want this VM to be part of an existing cloud service? I'll do a new one. There's the name. Where do you want to put it? Well, I'll put it in Europe. I'm already in Europe. What storage account do we use? It looks right to me. Knows that my storage account in Europe is called Mark EMEA Storage. And then what's my endpoints? How do I want to connect to it? I want to connect PowerShell, remote desktop. Maybe I want to build a web-based front end to it, so I'll build an HTTP endpoint. And that's it. I'm now provisioning a pre-configured data warehouse. Now, I picked it small, all right, but you could do up to 8 cores configured. Alexei, again, will talk about this in great detail on tomorrow. And I'll point to that session. So right now, I'm actually creating a data warehouse, and I'm also creating an HD Insight provision server right now as well. How's that going over here? Looks like they're both going pretty well. Let's go look at my cluster. It's probably going along farther, still in the Azure VM configuration stage. All right, so I'll come back to this if you don't believe me, that it actually will get created in the next 15 minutes. And the only other thing that I will do now is I will bring up Excel just to show you, since ODBC is already in here, connected, and kind of Judy was showing you this morning behind the scenes. In this case, I'll just use Power Query, from other data sources. Again, you've seen that before. From other data sources, I will go down to HD Insight, and I will type in the name of the storage, and this is Markham Storage, if you remember that name. And there's not going to be anything out here. It'll be a pretty much empty machine, but that's it. Now I'm connected to the server. It wasn't very hard. You started pretty easy. At least get you creative thinking that I could do it this way. And again, I could bring this data into Excel if I wanted to, but it's kind of boring data because I haven't done anything yet. All right, so all cool. Just to hopefully get you thinking a little bit. Now let's go back and we'll go back and look later. Now let me tell you what's behind the scenes. The Hadoop cluster looks a little bit like this. If I just take a pen, so this section right here, this is open source Apache we put on the cloud. We also have a Windows version that we go through Hortonworks, and you can do a Windows distribution, or you can do a Linux distribution. That's fine as well. All right. The nice part about the cloud is it's all provisioned for you, like I showed you. Now, Hadoop is HDFS is a file layer, Hadoop file system. Above that is the map reduce layer. But what we did is we wrote a thin layer on top of Windows Azure Blob Storage to make this act like HDFS. Why is that cool? Because all it is Windows Azure Blob. So what does that mean? You can take full advantage of the Windows Azure Blob features that come with it. Triplicate copies are made of your data automatically. You don't do anything. All I have to do is copy my files into the Azure Blob system. They become Hadoop aware. No loading data through Scoop or anything like that. That's pretty cool. My proof of concept is now up. I copy files in. I'm off to the races. All right. Some thoughts, some examples of doing it a little quicker than you do it today. Okay, let's keep going. This is the virtual machine idea that I was showing you, but you can do up to a terabyte, up to 8 cores. We do have a paper out on MSDN, and more important, Alexei is tomorrow at 10:15. Hopefully I got that right, Alexei? Yeah. All right. Okay, that's an example of just making any part of the steps you can improve. You can be faster than today. I showed you the provisioning step of doing a proof of concept faster than you do today. How about the middle layer? How about this ETL stuff? Can that be done faster than we've done today? Well, if I'm the IT pro, let me come back to this. If I'm the IT pro and I want to scrub the data, or if I want to figure out what data, what do? I go to the expert of the data. Maybe we have a meeting, we sit down. Maybe it's a long meeting. Maybe they're part of the process. And then I go back and try it. Then I go back to them, is this right? No, change this. I go back and try it. Or I just allow them to do it, or allow them to do part of it. All right? That's kind of what Judy showed a little bit in the demos today, with a little bit of mashup inside Power Query. Introduce those type of self-service wherever possible. All right? The flipped idea about maybe I process it first, then put it in the data warehouse, another great way to look at that. So let me introduce you to a concept. Again, we talked about if an end user wants access, as a professional, I got to give them data connectivity. What if there was a catalog? You notice I spelled catalog in Swedish. How about that? That's my whole contribution to the community. All right. Thank you, Tobias. What if? Now, I wouldn't tell you that this is real because that would be confidential, and I wouldn't do that, right? But if you ever heard me speak before, you know what I might be talking about. But what if this existed? What if this catalog had all my data sources pre-configured, controlled by us, the data professional, the IT professional. We controlled it. We put security contexts on it. We made it private where it needed to be private. We made it public where it needed to be public. We controlled this, and all existed in there. Public data, private data, anything we control. What if that already existed? And, you know, I have 2 children at university and 1 in high school. And the kids today, like many of us, if we're sitting around eating dinner and we have that question about, ooh, what's the capital of a state, or any question we're talking about, what do? You don't wait and go look it up later. They get their phone out and they look it up right away. I mean, they're built into, if I have a question, it's all answered. It's right there. I do search. Well, what if we actually treated data in a warehouse like searches for the same end user, the same experience? What if they could say, I just want data related to HR in my company. I want data related to claims processing. What if they could just say that? Search for that. And we provide them data sources automatically from that. Public and private, including external web-based. Judy showed you this morning a search, and I don't know if you caught it, but that's a indexed Bing search that's done of Wikipedia. That's only step 1. What if we could do that with a lot more stuff? What if you could add to that as well? And that's all stored in, I don't know, something called a catalog. And so we can just say, I need claims processing data in English, and maybe I get back data sources already. All right? But well, I'm the IT professional. I'm a little bit worried about all that access to data. Guess who manages this, governs this, makes sure it's all high quality? We do, the professionals. All right? And because we have the ability to administrate it. That would be pretty cool if that existed, and that would come out, I don't know, next year or something. All right? So don't tweet that. All right? Because I never said it was. So this is Power Query. This is my ugly, this is as good as I do PowerPoint. So I have an ugly thing over here called Power Query Excel. That's not ugly, my box is ugly. So I have this thing called Power Query, and the experience of the end user says, okay, all right, what's going to happen here? All right, I want information. I might turn around and do a search, and it might come out to public site. Oh, look at this. There's something called a catalog here. If that existed, that'd be cool. Or I might do the same search, and it might come into my corporate data, and it come back data sources right into Excel. Or these data sources might be anything. Could be, you know, Hadoop, could be DB2, could be flat files. It just comes back and I can start working with it. All right, that's kind of saving me time as an IT professional and building data warehouses quicker than you do today. This is kind of the thinking. This is why self-service is there. It's not to take away control, because control is there. All right, it's not to, it's actually to speed up the process, as well as free us up as IT professionals to actually do bigger and greater things as well. So I'm a believer in self-service. It is a concept that you want to try. So let's go now do something, I don't know if this is interesting or not, but let's go do, back to Excel. I'm now going to walk through what Judy did this morning quicker, because you've already seen the demo. But now I'm going to be in the eyes of an IT professional. I'm actually thinking these, so think like I'm going to think now. We're IT professionals, and we're going to walk through that demo. Okay? Let's see if I can even remember that, because I suck at demos. All right. So I believe she went to Power Query, all right, and she went to other data sources, and she went to Hadoop. Okay? All right, that's what she did. But before we do that, all right, we could, you know, online search, all right? And again, this catalog doesn't exist today, but if it did, this would be the experience. Right now, this does work with Wikipedia. It's all indexed out there. All right, so I can type in anything here. I can type claims processing, or I can, you know, be the NSA and then type in Sweden government. All right. By the way, this is all public data. I'm really not illegally doing anything here. All right. So, and again, data comes back to me automatically, and I can do that. Same experience, just typing words, just like my kids do, and just like we all do when we have a question, and comes back data sources. And these data sources on the right-hand side could be anything, all pre-configured and managed by us. And then when they use it, what do they do in Excel? They mesh it up and they add other data to it. Then what happens to that data? It either stays in their spreadsheet. Did it ever come back into the model? Why not? Why not come back? Why not turn around, managed by us, put it back into the model, and now I have new data sources as well. Tightly configured data sources. So that's just the experience. But let's go through now the Judy demo real quick. And what she did was she was in Power Query and she did other sources. In this case, she actually went down to Hadoop and she typed in a name of a storage. Hopefully, if a catalog ever exists, we won't have to do this part. All right, so again, IT professional, I set up the data sources, access to data sources without getting that call saying, I need access to, I don't know what I need, I know I need access to claim, can you go find it for me? It's all there waiting. So as an IT professional, I thought that was pretty cool. All right, and then she went to the stocks, data. Now, she actually hit this button over here and she cleared CSV out and cleaned up the data. But how does she know that as an IT professional? The end user knows that. So if I, as an IT professional, if they know the data, why don't we give them the tools to do it? Again, the data is already secured by us. So we're doing the security part, all right? And let them, instead of wasting time and making a phone call, setting up a meeting for next Tuesday to figure out I had to do that command, let them do that command. All right, well, that's okay, that's a good idea. What else did she do in here? She clicked on, I believe she clicked on the binary to bring data in. I believe she did. Right there. Yeah, thank you. All right, and then data comes in, all right, and again, they can call us up now and we could say, all right, what do you want me to do with this? And then we could say, well, why don't you split that column up and make it into different columns, all right? And, maybe we don't know what the data is. Do we know this is a symbol? In this case, we do. But again, I'm an IT professional. All I'm doing is being administrator. What do I do now? Well, you type in symbol, all right? What do I do now? So basically, again, as IT professional, the data is secure, I'm just giving them the ability to actually manage that data. And again, this data over here format, do I really know sometimes that this should be a number or a text? What if I guessed and I put the wrong data type? They only know, because it's their data, will give them the ability to change it. So this is not sophisticated ETL by any means, but it's saving us time because we're answering the questions, putting it in charge of the people who actually know the data. So that was all fine. I'm not going to change every column on the demo. And she bring it back up. And now here's the thing that happens more often than you would want to admit or you'd want to know. External data is added to this. All right? Maybe it's just column names or maybe it's just clarifications. But what Judy showed is she went back to Power Query and they brought in, not Swedish government, they brought in S&P 500. And I missed. Thank you. All right. I told you I'm very bad at demos. Interesting. As a general manager, I usually get people to do demos for me. But if I have to really show you self-service, I should at least do it myself. So she brought in S&P 500. It doesn't really matter what this is. All right. She brought this data in. The point being is they're probably modifying data into that spreadsheet. Data now that you no longer have control of, or we no longer have control as IT professionals. And then what she did is she did a merge, and it doesn't matter. Well, at this point, let's go through and do what she did in the merge. And she just simply joined on these columns. And I'm saving a few steps, but the merge is now done. And then again, what data do you want? I can go ask the end user, or let the end user pick themselves. I want a company name, and I believe she picked sector and address. All right, only the person, the user knows it. All right, now what she didn't show is, all right, my favorite part is, this data is really what the user wants to share. And it's modified. So why don't we load the data model? Let me go zoom in on that. Let me go load the data model. And now I save this, and now as from IT perspective, this becomes a new data model that we approve, that we put security context on, that we insist, that we make sure that's refreshed when it needs to be refreshed, things like that. So all of a sudden, instead of we creating a data model from scratch based off 100 interviews, the user actually created a new data model, which was modified. And for the first time, we actually get control over the ability that data that was actually merged and data that was actually massaged is now back into the context of security of the IT professional, which is what we want. So that's just, again, another example of, as an IT professional, I got more done quickly and I still maintained control. Okay? That's as much as my data skills of demoing takes me. So let's keep going. Let's do something else. Let's go see if my stuff actually got done. We look at that. Yeah, my cluster is actually completed. How about my VM over there? Did that get completed too? If I go to virtual machines, yeah, that got created as well. So just so I wasn't fooling you, that actually got done. I thought I'd throw in a couple best practices when this session went from a breakout, which whatever breakout session is, to opened up to everybody. I figured I'd throw in a couple best practices for Power Query from experience of my team. A couple things, there is no governor right now, and you could actually bring in more data than it should actually hold. So just knowing that, going in, educate your users that, hey, Excel can only hold what Excel can hold. All right? So be careful about that. If you're putting data, if you're going after Hadoop, there's good ways to put files in Hadoop, and there's bad ways. Put the files in Hadoop exactly the way the user thinks. All right? If they think by vertical, then put retail here and finance here, etc. Don't mix them all up. All right? Set it up so when it's presented to the user, it comes back either date range or whatever range that makes sense to the way they work. So that's a little tip. Again, there's no governor and does not read compressed files at this point. So this is a few tips to take with you. All right, reports and all that. All right, again, the IT model, I actually showed you an example of building it automatically. Okay, so here's, at this point, I just gave you simple examples. How to do a proof of concept quickly, how to turn over some of the data decisions to the end user and maintain your control. All right, there's many more things you can do here as well. For example, maybe what you do is this data warehouse already exists, all right, and all you do is apply in-memory technology to existing data warehouses. So, actually, Pivot Power View, I guess, I had to put in a good word for that, but I'm not going to double that. You've seen that 100 times. So maybe I turn around and I show you in-memory technology, okay? And then you apply in-memory technology. Again, faster, all right? If queries run faster, it's faster. So it's just not the setting up. You can actually use in-memory technologies. And to me, to get to real time, all you can use is really in-memory. So I showed you Stream Insight, a couple examples. You know about column store with SQL Server 2012, although 2014 it's updatable now. So that's we enhanced the column store. Now here's an interesting thing. We're releasing SQL Server 2014, and there's a great session on this. We call it Hackathon. It's actually we're going to release it as in-memory OLTP. which is actually a kind of silly name because 40% of my TAP customers are using it for the ODS of a data warehouse. What's the ODS of a data warehouse? It's just load data in, right? You load data in really, really quickly. Well, if you're going to load data in really, really quickly, why aren't you using in-memory technology that exists? So if you haven't seen this, let me just show it to you. All right, and we'll do my last demo. All right. Where are you, demo? There you are, I think. Okay, and my screen size, I had to lower the resolution so they could do the video. All right, this is just an application, but I'm going to show you the code behind this as well. Here's an application that does basically video selling online. And since the resolution is bad, what I'm going to do over here is I have all my product listings. You can see it was updated more than a day ago. And I have all my product listings, but it's just not a product listing that comes back. It's some intelligence built into it. So this product listing does things like a hot list. Well, how do you determine a hot list? I have to look at the purchase order history table, and then turn around and recalculate it and post it back up here. There's something called a baseline over here, and I'll show it to you, that today, my resolution is so bad. I'm going to just play around and show you back and forth. All right, that actually takes 25 minutes to run. Okay, that's why, and this is up 24/7, so I don't run that all the time. Right above that is recommendation latency, and I'll show you what that is in a second, but the bottom line is when you ever go purchase something on any site, and then it turns around and says, you might also be interested in these things, that's recommendation based off what you're purchasing and who you are. And then the top one is just how fast it takes to do throughput transactions per second. And so I'm going to start the demo up, and what's going to happen is you're going to watch transactions per second get up to right about 1,000, okay? And that's just a simulated set of tests of throughput based off a user count that I set. So that's sitting around 1,000 transactions per second. Now I'm going to turn around, I'm going to take my orders table, and I'm going to put it in memory. All right, and I'm going to apply that in-memory change, and I'll show you the code for this. And then, just because it's now in memory, and there's no latches or logging information, I'm now up at 30x, 21,000 transactions. Well, what did I just do? Just so I show you, what I just did is this. There's a new command called with memory optimized on. You don't change any code, you just turn it on. You put that table now 100% in memory. If you don't have enough memory, it doesn't work. All right, so you do need enough memory to put that table, and that's all we really did for this example. All right, but that we can actually do more. So besides thousands per second, I might turn around and decide I'm going to come over here, and now I'm going to go buy something. I'm going to go buy this this game, and when I buy this game, here's that recommendation list I talked about. About 6 seconds later, it calculated, oh, if you're going to buy that game, you will be interested in these games as well. Okay? As a matter of fact, when I come over here for this thing, and I want to buy this thing, it'll take a certain amount of time as well. All right, so anyway, those recommendations came up, but I think I can do better. So what I can do, sorry for resizing the screens, I'm going to come down here and I'm going to recompile my stored procedures as native. All right, and let me show you what that is. It's brand new. It's a new command called with native compilation. All right, and below that you can see begin atomic, which is actually new as well, to treat this as one transaction. What I'm actually doing is I'm taking the stored procedure and I'm really making it like a DLL, and I'm passing it to my Hackathon engine. And I'll show you how the Hackathon is in this engine that does this code. So this engine is really it's embedded in SQL Server. There's a relational engine, there's a storage engine, and in between the SQL Server, I also added right now in-memory OLTP and in-memory column store in the middle. And the reason that they're separate is because it's a lower code base. To go fast, you don't want more code, you want less code. Also doesn't do any locking and latching, things like that. All right? So what I'm really doing is also takes this native DLL you're allowed to pass it to it. What does that do for me? Let's go take a look. What that does for me, now my latency is 0.7 seconds. Okay? Let's actually go do one. I'll come over here, and I'll make this bigger. I should never give in to lower my resolution. All right? So let's go back, and I'm going to refresh the screen on my application. And what happens now, when I refresh the screen, you can see my recommendations come up in 0.7 seconds. All right? And then I can turn around and I might want to buy the boxing game. Okay? And if I can buy the boxing game, that's how quickly it comes up. And if I turn around and buy the boxing game, it will turn around and also change my what's hot list as well. So anyway, 3 examples of using in-memory technology just to speed up your queries. All right. And this is the architecture for it. All right. Basically, it's in memory between the storage and the relational engine, where there is, it's just not a table in memory. You can do that anytime you want. You can do it today. All right. But there's a complete new latching model. Interestingly enough, it went back 30-something years when they created relational databases. There's a great presentation by Dave DeWitt. If you go to the Wisconsin EDU website and look up Dave DeWitt, he'll actually go into much great detail explaining the architecture behind this. But there was a concept created 32 years ago when they were actually creating relational databases, more than that, probably like 35 years ago. And they actually had 2 models. One was latching and locking, which actually doesn't actually hold it. It's actually more of a voluntary type of latching, it's optimistic. And the other one is the ACID properties, which was adopted and applied for the last 30 years. It's actually going back to the original model created 35 years ago of optimistic, and actually that's what we applied here. So no latching, no logging, all optimistic. All right? It actually is controlled and created and corrected, but it's a combination of that plus the native stored procedures plus the reduction of code base, all in memory is what gives you that performance, and no changing of your application code. So that's a good example as well. And again, there's another a session on that. All right, so I'm not going to go through the example, but this is the PowerPoint will be available to you. This is an example of, when you turn around and create it, what happens? It moves into memory. It's a different code base. All right, to come down here, process it, so the query optimizer, relational engine knows about it. All right, and it's all in memory, and it knows about the native code as well. All right, so let's finish this up. I believe, if I remember right, that I am now at an hour. So I don't care what your data source is. Could be anything. All right, files. All right, whatever your data source is, think about keeping unstructured, unstructured, and structured, structured. All right. When you create whatever consumable form for your end users, think about the flipped idea of maybe I process the data first and that helped me create my model. It's potential. Maybe I let my users help me create the model, as long as it can come back into controlled by me, the IT professional. Again, speeding that process up. And then whatever set of tools you want to access it, to me it really doesn't matter as long as I'm answering questions at a faster pace than I do today. So hopefully from this you saw some ideas on how to do it faster. I promise you again that if you do it faster, there will be no complaints throughout your organization. I thank you for your time. Jim and I and Judy are here from the engineering team. We could be around for just a few more minutes before we have to head to Singapore where it's 30 degrees Celsius. But what the heck. But anyway, thank you again. It's been great seeing you all at the session. Thanks for coming.